Good evening, everyone. I don't know why Dr. Nanda chose me, an anesthetist, to be a part of SPOC, but probably because we put patients to sleep, she gave me to moderate a session on sleep. Now, we have heard a lot about exercise, diet, and various other strategies to improve immunity. But whatever we do, without a good foundation of sleep, nothing works. And every animal on this planet sleeps. And when we sleep, we are the most vulnerable for attack. But still, evolutionarily, we have been given this sleep to get back to our normalcy. And there is something much more powerful than a simple 8 or 9 hours of nap. So to take us through this interesting topic, I will hand over the mic to the speaker, and I request the speaker to kindly take over. Thank you.
Thank you, sir. So I am Dr. Sharan Singh. I'm a principal from Padmavati Medical College for Women, and you can imagine my plight. So I thank Dr. Nanda for giving me this opportunity. And like what the moderator has told, I'm also not very sure what I'm doing in the midst of such a galaxy of personalities in the field of oncology. But still, because everything starts with physiology here, I'll just try to put some light on the effect of circadian rhythms and sleep on cancer. So can I have the next slide, please?
Doctor, you're already sharing it. Can you go for the slideshow?
Yeah. Yep. Yeah. So I have structured my talk around these headings. I'll just give a brief introduction, the physiology of circadian rhythms and sleep. And also I'll try to shed some light on the influence of circadian rhythm and sleep on cancer, and end my talk with a bit of applied aspects. I did a lot of references, couldn't make much out of what I read, but these two articles were the ones which I felt helped me the most in preparing for this presentation. So we all know that in our body, we have an internal biological, which is the suprachiasmatic nucleus. And this nucleus is the one which keeps time and tells all the other organs about what is going on. So the word circa means around 24 hours. And this is the clock. The suprachiasmatic nucleus is the one which is maintaining some of the circadian rhythms which are going on in our body. One circadian rhythm is the sleep-wake cycle. So some cycle which is going on around 24 hours, we call it as a circadian rhythm. And we have so many examples of circadian rhythms. And one of the highlights which I would like to make here about a circadian rhythm is about melatonin. So melatonin secretion starts around 9 o'clock and it will stop around 7:30 in the morning. Now, the suprachiasmatic nucleus is a free running clock. It will just run freely. But this suprachiasmatic clock has been entrained to the day-night cycle which is going on outside in the environment. So how is this entrained to the day-night cycle which is going on outside in the environment? It is by this simple pathway. So when light falls onto the retina, the information is sent to the suprachiasmatic nucleus. And this pathway is the retinohypothalamic tract. And from the suprachiasmatic nucleus, the information ultimately goes and reaches the pineal gland. So what happens is, when it is daytime, the pineal gland will stop secreting melatonin. And when it is night, the pineal gland will secrete lots of melatonin. The melatonin secretion shoots up. So melatonin will go to all the other organs in the body and tell them it is night. And then melatonin levels drop, that tells the body organs that it is daytime. So this is how this free running suprachiasmatic nucleus, which is a biological clock, is entrained to the day-night cycle which is going on outside in the world. And how how the melatonin secretion is going to tell all the other organs about what is going on outside. Now, what is the significance of this? So now it is not just a simple factor that melatonin secretion will tell it is day and night. Melatonin has got an important role to play in physiological and pathological processes, like I already told you, including the control of circadian rhythms, retinal physiology, seasonal reproduction. And what is relevant to the talk and the seminar, which this whole conference which is going on, it also plays a very important role in regulating cancer development and growth. Believe me, this was something unique which I read through this whole preparation for this talk. And again, I'm very thankful to Dr. Nanda for giving me this opportunity. Okay, so moving on. Not only that, it also has a role in regulating the immune responses of the body. And we all know that immune responses are also very important in tumor cancer surveillance, especially the cytotoxic T cells. And also it has antioxidation, free radical scavenging, regulates mitochondrial respiration, and so on. Other parts are there. Now, regarding the role of melatonin in tumorigenesis. So if melatonin levels are at the normal level, so it will suppress the initiation phase of tumorigenesis. So the mechanism is probably it prevents the accumulation of DNA addicts, and these DNA addicts are known to cause neoplastic transformation. Now, how is melatonin doing this function of suppressing tumorigenesis? So basically, like I already told you, it acts as a free radical scavenger, and it also helps in detoxification of carcinogenesis via a biochemical pathway, that is the glutathione related antioxidant pathway. So now coming to the role of melatonin and its action on immune system. So it is known to produce a wide variety of cytokines, and these cytokines in turn influence the activity of circulating T lymphocytes. And melatonin is important for the function, synthesis, and release of immunocompetent cells. So we all know that endogenous melatonin interacts with the immune system, and it has both endocrine, intracrine, autocrine, and paracrine mechanism of actions. And mainly it regulates the interleukin-2 and interleukin-2 receptor systems, and thus it has an oncostatic action on the cancer cells. So now coming to how to fit all this knowledge into perspective. So in modern 24-hour day societies, the overall prevalence of sleep disturbance and daytime sleepiness has increased. We all know this. If you take a class for today's youngsters, you'll know how difficult it is to catch their attention. So also exposure to artificial light, especially during the night, which was seen in night shift workers and people who are habituated to watching television in the night. This has altered our lifestyle so much that people started thinking that, yes, this could be one of the reasons for the increased incidences of cancer. One example is people have observed that increase in breast cancer just could not be accounted with the modern lifestyles and other things which are put forward. They just could not account for why there was sudden increase in breast cancer, and then they started thinking on these lines. So exposure to artificial light and at night in the built environment in the causation of circadian disruption. So we all know, after you understood the basic physiological pathway which I told you, so exposure to artificial light can cause circadian disruption, and it will suppress the nocturnal melatonin production, and this can cause a variety of human cancers. So how does this happen? See, basically at a molecular level, to put it in, again, I'm trying to simplify things. Whatever I have understood, I'm trying to tell here. So if you go to the molecular level, there is a crosstalk between the circadian clock machinery and the cell cycle, repair, apoptosis, senescence, autophagy, and other oncogenic and immune pathways. So circadian perturbations means disturbances in the circadian systems in the body because of decreased melatonin secretion can lead to all these problems which have underlined: uncontrolled proliferation, abnormal apoptosis, metastatic spread, immune invasion, increased angiogenesis, and resistance to the cancer drugs. So which are all the hallmarks of cancer. So also they have observed in so many studies that multiple loss and gain of function studies with cellular and animal models have shown the involvement of clock genes in cancer predisposition and development. So some of the cancer genes and their products are this BMAL1 and other clock genes. So they have if they're inactivated in the animal studies, they have shown to cause an increased incidence of all the cancers which are listed out here: hematological cancers, colorectal cancers, pancreatic cancers, cancers of the tongue, breast, lung, hepatocellular, nasopharyngeal, glioblastoma, and so on. The list goes on. Maybe many more will crop up. So also, on the other hand, overexpression of circadian activators will suppress, they have seen that it suppresses in animal models the malignant phenotypes by various mechanisms, which you all can refer. One is that p53 dependent apoptosis. So also then they did other studies where down regulation of these products of those BMAL1 and clock genes, PER1, PER2, CRY1, all these are products of those genes. And they have shown to promote or suppress tumor incidence and proliferation respectively. Now there is a bit of controversy which is emerging when I went through all this. Adequate sleep is known to cause suppression of cancer, but they have also found that excess sleep can lead to other types of cancers. So the jury is still out on this, but we can safely say that good sleep of 8 hours duration is very much essential, and it plays a very important role in prevention of cancer. So other mechanisms I've just mentioned there. So some studies have shown that the core clock genes exert tumor protective functions, but here there is a catch. The catch is it all depends on the cancer cell status or the type of the cancer. So if this gene BMAL1 gene, which is regulated by melatonin, if it was silenced, they observed increase in apoptosis with mitotic and morphological abnormalities in this cancer. And knockdown of that has found to induce cell cycle arrest and apoptosis in other types of cancers. So like I already told you, the jury is still out on this, but you can safely say that around 8 hours of sleep is a very important preventive measure for cancers. And the suprachiasmatic nuclei, I already told you, it is entering into the day-night cycle by the retinohypothalamic thing which I mentioned. And it also causes rhythmic release of neurotransmitters and neuropeptides, and in the peripheral organ clocks via systemic hormonal secretion and neural innervations. For example, in the morning, you see a sudden spike of hormone glucocorticoid release, the stress hormone. So that is also being monitored, and that may also be relevant in modulating the cancer triggering processes, which are already mentioned. Non-photic external cues like the temperature changes, food intake, exercise, and pathogens, they can reset the circadian rhythms. For example, when we eat food, automatically the liver knows what time of the day it is. It is one way of indicating to the liver. Then a recent study has also shown that overexpression of this BMAL1 gene promotes breast cancer and metastasis by upregulation of expression of this matrix metalloproteinases. And the list goes on. So we have different types of cellular and molecular mechanisms because of this. So finally, to say, altogether, these results suggest divergent roles of circadian clock genes in pathogenesis depending on the type and or state of the tumor cell. So consistent with these results, just given, they have analyzed 32 human cancer cells. They're trying to correlate those studies which were done in the animal models to human cancers, and they have found that many of these clock genes were downregulated in so many cancers. So what is the applied aspect for all what I have told you? So there is something called as chronotherapy. So you can not only give the appropriate dosage of the drug, the timing at which the drug is given is also important. So using the knowledge of the circadian rhythms, we can do some interventions for cancer. One is by training the internal clock. So we can do interventions to enhance or maintain a robust circadian rhythm in feeding, fasting, sleep, wake, or light dark cycles. Or we can drug the clock using some small molecules that directly target a circadian clock, and or we can you can use clocking drugs which optimize the timing of drugs to increase the efficacy and reduce the adverse effects of some of the cancer drugs which are being used. So they have found that giving cancer treatment in the particular site at a particular time is more efficient treatment of cancers. So finally, I'd like to say that circadian rhythms have to be maintained. Ultimately, it all depends on the circulating melatonin levels, and good sleep ensures adequate melatonin levels. Oversleep also is found to promote the cancer incidence of cancer cells. And thank you all, sleep healthy. I thank you all for listening to me patiently.
Thank you, sir. It was a wonderful talk. Just have a question. If any questions from the audience you would like to take, because we still got a couple of minutes left.
Couple of seconds.
Well, sir, 1 minute now.
I have.
I just have one question from from my side. Now we have seen a lot of disruption in sleep, especially in the last 15 years after smartphone came, and now in the last 5 years or so, especially with the television coming into our hands. Now people are probably sleeping. I get a lot of patients. I do chronic pain, so I get a lot of patients who sleep quite late. They tell me that they sleep at 12, 1 o'clock. Now, is there anything when you went through the research, which looked at any new research coming out due to this change of habits?
Yes, sir. There are a lot of research going on and a lot of studies which have been published, which show that disruption of the sleep-wake cycle, unhealthy sleep habits. It's not only how much you sleep, it is when you go to sleep, when you are awake, so that you try to maintain the internal clock circadian rhythms which are going on, like the release of the stress hormones and all that. All that should match your sleep-wake cycle. If things are not matching, definitely it is going to cause the increased incidence of cancers. There are many studies supporting this.
And just a last question, because we have audience who are non-doctors and non-medical people, the role of melatonin, because melatonin is a over-the-counter drug, especially in the Western world and also in India. Role of melatonin, because we definitely are secreting less melatonin with the increased exposure to blue light. So role of melatonin in probably regularizing sleep and probably in the long term decreasing cancer occurrence.
So if you look at the theory, sir, definitely melatonin medications should play a role in preventing cancer, but this requires more large-scale studies to support this. Definitely, looking at the theory, what I have presented, you can say take melatonin. It should help you to prevent getting cancer. But the jury is still out. We don't know whether it is the internal melatonin secretion which is more important than what to take exogenously. And one thing I don't know whether I missed it out. The immune cells can secrete melatonin. T lymphocytes, when they are going into the tumor cells, they secrete local melatonin there. That has a very important. That plays a very important anti-cancer effect. So by giving melatonin by other means, we don't know whether this effect will be seen.
Okay. Thank you, sir. Thanks a lot. Thank you.